how does observation affect reality in quantum physics? Imagine watching a tiny particle and suddenly it changes its behavior. That's not a sci-fi story, but a real phenomenon in quantum physics. When scientists look at particles so small they behave like waves, something strange happens. The act of observing actually changes what the particle does. This is called the observer effect in physics. Unlike everyday life, where looking at something doesn't change it, in the quantum world, just measuring or watching can make a particle switch from being a wave to a particle. The key idea here is the wave function. Think of it as a cloud of possibilities where a particle can be in many places at once. When no one is watching, the particle exists in a superposition of many states. But once a measurement happens, the wave function collapses. That means the particle picks a specific position, energy, or state. This collapse isn't just about recording what's there, it actively changes the particle's reality. One of the clearest examples of this is the double slit experiment. When particles like electrons or photons pass through two slits without being observed, they create an interference pattern on the screen behind. This pattern looks like waves overlapping and passing through both slits at once. But if you set up a detector to see which slit the particle goes through, the interference disappears. The particles then behave like tiny balls passing through one slit or the other. The simple act of watching changes the outcome completely. This effect isn't about human consciousness directly influencing reality. It's about the physical interaction between the particle and the measuring device. When a detector interacts with a particle, it disturbs its state, forcing it to settle into a specific position or energy. So, in quantum physics, measurement and observation are inseparable from the system itself. From a strange science perspective, this means that at the smallest scales, reality isn't fixed until it's observed. Particles exist in a fuzzy state of possibilities until measurement forces them into a definite state. This makes the universe seem more like a place of endless possibilities rather than fixed facts. This phenomenon is also important in developing new technologies. Quantum computers, for example, relying on controlling superpositions of particles. To do that, scientists must carefully measure quantum states without destroying their delicate superpositions. Understanding how observation affects particles is key to advancing these cutting-edge devices. In the end, the observer effect in physics shows us that in the quantum world, reality isn't just something we see. It's something we help create through the act of measurement. It's a strange, fascinating twist that challenges our everyday ideas about how the universe works.